So right now we're going to take a few minutes to analyze the circuit as we normally would do in class. We'd do one together and then you'd go off on your own and finish the rest for homework. So first thing we have to do here, we have three total resistors, R1, R2, and R3. And it's important to note that R1 and R2 are connected in parallel. Current can split, but all the current goes through R3, therefore R3 is in series with the battery. And EMF is just another word for voltage, just a little kind of older vocab. So the first thing we have to do, one way that I like to picture these resistors when they are in parallel is you can picture it as one resistor. Let's call it R12 just for now. And R3 is still the same, which is 9 ohms. Now, remember when we are adding resistors in parallel, we have to do the 1 over rule. So it's going to be 1 over R1 plus 1 over R2 equals the equivalent resistance. So here we do 1 over 4 ohms plus 1 over 12 ohms equals 1 over the equivalent resistance. And we could find common denominator, multiply left one by 4, or you can, in your calculator, just use the -1 feature, also very helpful. And we should get that the equivalent resistance of this pair of resistors is 3 ohms. So in a separate circuit, this one single resistor would act as a 3 ohm resistor. Now, when you are determining the equivalent resistance of the 3 resistors, well, now we have a nice series circuit. All the current is only one path for current to go. And when you find the equivalent resistance of a series circuit, you just add them together. So it's R12 plus R3 equals REQ. So for our equivalent resistance, we should have a total resistance of 12 ohms. On to part B, where we are going to find the voltage of the battery in this circuit. And for this, we're going to use Ohm's law. R equals V over I, or I like to think of it as V equals IR, depending on what you're given. But for here, we're looking for the voltage. Since the current through R3 is 0.4, that means the current at any point in the circuit, as long as it's not split, so through R2 and R1 will be different, but every other point will be 0.4 ohms, 0.4 amps, excuse me. And we found that the total resistance is 12 ohms. Multiply those out, and we should get a total voltage of 0.4 times 12 is 4.8 volts. All right, so part C, here's where it's very helpful to know your rules for analyzing circuits. So what we're looking for is the potential difference across R1. And since these two are in parallel, the potential difference across R1 is going to be the same across R2. Now, what we can do, if I go back to the original circuit I drew with the 2 resistors, we have the 9 ohms, and we said it was equivalent to a 3 ohm resistor, or it really doesn't matter, we could look at it here. What we do know is that, let me use a different color. For R3, we can do Ohm's law specific to R3. And R3 has a current of 0.4 amps and a resistance of 9 ohms. And when we multiply that out, we get 3.6. So that means the voltage drops. If we were to set up a voltmeter, measure that, we would do it across. The voltage drops 3.6 volts across R3. But our voltage drop across R1 and 2 has to add up to that 4.8. So our total voltage in the circuit is 4.8 volts, and the voltage drop across R3 is this 3.6. We could subtract these, and we find out that there's 1.2 volts left over. Therefore, the voltage drop or the potential difference across R1 has to be 1.2 volts. Okay, so now for part D, we're going to be looking for the power dissipated in R1. And first thing, let me get rid of this. First thing that we have to do is figure out the current that's going through R1, because the power equals IV. You could also rearrange Ohm's law to solve for it a few different ways. But for now, I'm going to use the formula current times voltage, where we do know the voltage across R1, and we don't know the current yet. So we can use Ohm's law for R1, where the voltage across R1 is 1.2 volts. We're looking for current, and it has a resistance of 4 ohms. So we get a current of 0.3 amps through R1. Now I can go up to my power formula. Power equals this 0.3 amps times 1.2. Therefore, we should get power, we multiply that out, we should get 0.36 watts. Now for part E, we're looking for the total amount of charge that passes through resistor R3 in 1 minute. Remember, we never use minutes, so I'm just going to write 60 seconds, so I know to use that later on. Now, amount of charge, that's going to be in coulombs, so we're looking for Q. I'm going to use the formula I equals delta Q over T. The current, we're going to assume it's constant, through R3. Total current in the circuit, 0.4 amps. We're looking for delta Q, and this happens in 60 seconds. Multiply that out, cross multiply, and we should get 24 coulombs of charge passed through resistor R3 in 1 minute. PJ, sit.